Hello everyone, myself Siddharth and I am here today to deliver a seminar about one of the important multiple access protocol which is known as random access protocol. So have you ever tried to speak in a room full of people all talking at once? So this chaos is similar to what happens when multiple devices try to send data over a single network station without any coordination. So today we will explore how random access protocol help this chaos by managing how devices share the communication channel, ensuring smooth data transmission. So in this session, we will cover key protocols such as these are the types of random access protocols like Aloha, CSMA, and its variations such as CSMA-CD, which is collision division, and CSMA-CA collision avoidance, and see how each handles the collision in data network. So if you see, when a sender and receiver have a dedicated link to transmit the data link control is enough to handle the channel since there is a dedicated path between the sender and receiver. Suppose if there is no such case to communicate or transfer the data between the two devices, in that case, multiple stations access the channel and simultaneously transmits the data over the channel. So it may create collision or crosstalk, so the data packets may lose, and it will affect the communication efficiency. So hence multiple access control protocol is required to reduce the collision and avoid the crosstalk between the channels. So if you see the hierarchy of the multiple access protocols, basically there are divided into three subcolumns. One is random access protocol, controlled access protocol, and channelized protocol. So random access protocol is subdivided into Aloha and CSMA in the sense control carrier sense multiple access. And it is again subdivided into CD collision detection and CA collision avoidance. And controlled access protocol, reservation, token passing, and polling. These are also very important. And at last, a channelized protocol. In this protocol, the available bandwidth is subdivided based on the frequency division multiple access and time division multiple access and code division multiple access. So, as I previously mentioned, in this tutorial, we are learning about random access protocol. In this protocol, all the station has the equal priority to send the data over a channel. In random access protocol, one or more stations cannot depend on another station or any station so control another station. So depending on the channel state, so whether the channel is ideal or busy, so each station can transmit the data or its packets. So however, if more than one station sends the data over a channel, there may be a chance of collision or data conflict. So there is no fixed time for sending data and there is no fixed sequence of stations to send the data. So basically, Aloha is one of the type of random access protocol. So it is designed for wireless LAN, but can also be used as a shared medium to transmit data. Using this method, any station can transmit data across a network simultaneously when a data frame set is available to transmit. So there are certain rules that Aloha must follow in order to make the communication efficient. So any station can transmit data to channel at any time. It is one of the rule. So it does not require any carrier sensing as it comes in next type of random access protocol. And data frames may be lost during the transmission of data through multiple stations. So acknowledgement of the frame exists in Aloha and it may also exist in CSMA-CA, which we will discuss later. And it requires retransmission of data after some random amount of time. So if a packet may not get acknowledgement after some specific period of time, back of time, which is termed as, it will retransmit the frame again if the back of time has been exceeded. So whenever a data is available for sending the channel stations, we use pure Aloha. So whenever data is available for sending in a channel, so then at the time we use pure Aloha. In pure Aloha, which is a subtype of Aloha. So when each station transmits data to a channel without checking whether the channel is radial or not, the chances of collision may occur and data frame may be lost. So when a station transmits the data frame to a channel, the pure Aloha waits for the receiver's acknowledgement. If it does not renew any acknowledgement, as I previously mentioned, it retransmits the frame. This specific period of time is known as back of time. So That's it. So pure aloha will works like this. So therefore it retransmits the frame whenever there is a unsuccessful transmission or the packet loss. And now comes to slotted aloha. It is another type of aloha. In slotted aloha, the shared channel is divided into a fixed amount of time, which is known as called slots. So if a station wants to send data frame into a shared channel, the frame can only send at the beginning of the slot, and only one frame is allowed to send at each slot. So if a station is unable to send the data to beginning of the slot, the station must have to wait until the next beginning of the time slot. So if so improvement over pure aloha. So basically sorted aloha has more advantages than pure aloha. So it reduces collisions by synchronizing the transmissions to slot boundaries. So next comes to carrier sense multiple access protocol. So it is based on media access protocol to sense whether traffic is present in channel or not. So whether the channel is ideal or busy before transmitting the data. It means if the channel is ideal, the station can send the data to channel. Otherwise, it must wait until the channel becomes ideal. Hence, it reduces the chances of collision or transmission medium. So it is of two types. In this slide, we are going to discuss about collision detection. So the CSMA-CD protocol works with medium access control layer as we previously know. Therefore, it first senses the shared channel before broadcasting the frames. And if the channel is ideal, it transmits a frame to check whether the transmission was successful. So at first, it will send only one frame. If the frame is successfully received, then the station sends another frame to the particular destination. So if any collision is detected, then the station immediately receives a jam or stop signal from the shared medium and to terminate the data transmission. After that, it waits for a random amount of time and again it starts communicating with the server. Now next is collision avoidance. So collision avoidance, it is also a protocol with medium access control layer. So in this protocol, when a data frame is sent to a channel, it receives an acknowledgement whether the channel is clear or not. If the station receives only one acknowledgement, that means the data frame has been successfully transmitted to the receiver. But in a case if it gets two signals, which is one from its phone and another from the collision frame, then then there is a collision occurred in the shared medium. So it detects the collision of frame whenever it receives a double acknowledgement. So this is the method used by collision avoidance in order to avoid the collision in the shared channel. So to summarize the session, in this session we discovered about random access protocol, which is one of the medium access controlled protocol to avoid the collision. So it is of two subtypes. One is Aloha, another is CSMA. Aloha in this stations can transmit data at any time. If the collision occurs, then retransmission will occur after a specific amount of time known as back off time. So pure Aloha and sorted Aloha are the two types of Alohas. So in pure Aloha, it can transmit data at any time, but in sorted Aloha, it can transmit only data at the beginning of the time slots. So next is CSMA, carrier sense multiple access. In this, the stations will check the channel, whether the channel is ideal or not, and then sends the data. If it is not ideal, then it will wait until the channel becomes ideal. So it is also two types. One is collision detection and another is collision avoidance. So it is also same as CSMA, but detects collision during transmission. So if there is a collision, then in CD, it will immediately send a jam or stop signal to the sender to immediate termination of the data transmission. But in CA, if it receives more than one acknowledgements, means one from its phone and another from the collision frame, then it immediately stops the data transmission and again it will start the data transmission after some time. So thank you for giving your valuable time.